Right, so we're here at the Linaro Connect 2013. So who are you?
I'm Wookey. I'm a Linaro person. I started right at the beginning, so I've been here 2.5 years now. I'm in the dev platform team.
So what kind of things are you doing?
I've been working for the last few months on the Debian Ubuntu ARMv8 bootstrap. So getting that working from nothing to a system you can actually boot.
So is it going to boot when the chips are ready?
Yeah, so the idea here is to have the distro ready before the hardware is, so that as soon as some hardware turns up there's actually something to run. And what's interesting is that Debian's always been a natively built system, but of course with no hardware to build on, that's awkward. So you've got to get yourself enough of a system to build a system at the beginning, so the bootstrap process. So that's always been difficult. So the Debian's done 20 ports in the last 20 years, so actually we do this every year, and we finally realised that treating it as an unusual event was dim, and we should make it so it was a bit easier. So in practice people used a different system, something like Open Embedded or Red Hat or something else that was already built for the architecture to bootstrap Debian on. So I've spent the last 3 years fixing the whole setup so that you can actually cross-build the initial port. So we've been doing multi-arch and cross-build supports and the ARM64 supports all in one go, which has been quite fun, and that's basically now functional. There's still a few things to actually push upstream into the distro, but it's yeah, it basically works.
So what's fun about this work?
What's fun? You get to do new stuff. So it's been very interesting working with GSOC projects. So I had a couple of students doing different aspects of this work. So there's a guy called Johannes Schauer who's been working on the theoretical part of the build dependencies. So the problem with Debian is that it's maximally configured to use everything, which means when you initially build stuff, every package depends on language bindings for Python and Perl and Mono and all sorts of things you haven't built yet. So there's a lot of circular dependencies. You can't build this until you build that, until you build that, until you build the other thing you haven't built yet. So we have to untangle all that. So there's a lot of theory in analysing the network and turning it into a tree so that you can actually start somewhere and build everything in order. So he's done a lot of the theoretical work on that using tools produced by the Mancusi project, which is a French research environment using Debian pretty much as an example of something really complicated set of dependencies to build on. And also Patrick McDermott helped with the actual tools to do that building, and a guy called Thibault Gurka did the toolchain work on multi-arching or helping to multi-arch the toolchains.
So how do you collaborate?
Almost entirely IRC and mailing lists. So obviously the GSOC project provides a bit of structure and time. It's basically done over the summer. So that's, you have to set a particular task which is small enough to be done by a student over 3 months. And in practice these tasks tend to expand, so you get some of what you wanted done, but not all of it. Fortunately, Johannes was able to make it into his MSc project, so he's been able to spend the rest of the year on that, which meant stuff's actually got finished rather than started, which has been good. Yeah, we might try and do that again this year. GSOC's just starting up again now, so we'll probably specify some more work along these lines, because the problem is that you get the kind of core work done, but that's not the same as getting it into the distro and finished and agreed. Debian's not the fastest project in the world to get details agreed. So we proposed some things. Generally we got good feedback. Everyone went, yeah, that's a good idea. Glad that's working. Then argued about the details of exactly how that's going to be put in for the long term. So we've still got to finalise that specification and get it in the next release. So
are you talking about university? Where is that?
I'm working at Linaro. Johannes is at University of Bremen. Patrick McDermott's at University in New York somewhere. I don't even know where Thibaut's at. He's at university somewhere, France, I think.
So just students, guys?
So GSOC is for students. So everybody has to be a student to be eligible for that project.
So how many students are working at Linaro? With Linaro?
So non-directly, this is really coordinated via Debian, that work. Free software projects enter into the Google Summer of Code to present projects and get stuff done. So I'm a Debian developer. Most of Linaro's work's actually done in Ubuntu rather than Debian directly, but for this core work, Debian and Ubuntu are effectively the same thing, and it's the same people doing the work. So it's a collaboration between Linaro, Debian, Ubuntu, and the Google Summer of Code thing, basically providing some money to get people to work on stuff for months at a time.
So,
get students
are
to
you Linaro?
I'm Linaro, but yes. So I'm employed by ARM, but seconded to Linaro.
So how long have you been involved with ARM?
Since a long time. Back in 1994, I got a job for Aleph1 doing ARM upgrades for RISC PCs. And then we did PC cards for RISC PCs, so that was running Windows on a x86 chip in an ARM system with emulation. And then around about 2000, we started doing ARM Linux work, so we're doing consultancy for people. ARM Linux was pretty new back then, so nobody knew what to do. So they were, there was a market for help. How do we make our ARM stuff work? So I did that for quite a few years.
90 what?
I started in 94. I've been doing ARM Linux since 1999.
That was like the early ARM Linux, right?
Yeah, exactly. It was brand new then. I did a port for the RISC PC. So it was the A5000 that Russell King did the original kernel port for. The RISC PC was a slightly faster RISC-OS machine. So getting ARM Linux running on that was a project. I did Psion Linux stuff. We did work with big project with Psion, who did. Now the Psion netbook was the original netbook, and they looked at running Linux on that as the standard distro. So we did quite a big project with them to get. So that was open embedded based, and we got quite a nice system set up. But in the end, it never actually got released. To be fair, it was a bit slow on that strong ARM based hardware, which I guess was one of the reasons why in the end they went with WinCE, I think, or something really boring like that. I worked with TomTom, the original TomTom devices, which was an early commercial Linux-based device. Some very clever Germans who did most of the hard work, to be fair.
Early 2000s? Or?
That was 2000 and something, I don't know, 6 maybe.
Did you say you were emulating Windows x86 in
on the RISC PC,
94?
On the RISC PC, yeah, back in 1994, we had second processor cards for RISC-OS machines. So the processor card contained an x86 chip. Back then it was a 386SX, and later on a Cyrix 5x86. And so there's pretty much just the CPU and an ASIC, which emulated there's a kind of data transfer mechanism that was fast between the x86 and the memory, so it was shared with the ARM chip, and so we could emulate all the devices. You either emulated the device entirely if it was something that didn't exist on that hardware, like a CGA video interface, or we just passed stuff through if it was a device like, there's actually a CD-ROM drive in this machine, so when you do x86 int 10 instructions to talk to the hard drive or the CD-ROM, those get passed on to the operating system on the RISC-OS machine to provide the appropriate disk block. And yeah, those were really popular for quite a few years. That was a reasonable business until RISC-OS machines basically got superseded by PCs everywhere. They were only ever popular in Britain and a bit in Germany, a few countries. So So Acorn, the company that made those, is what ARM eventually spun out of.
So you were there at Acorn?
I was never actually an Acorn employee, no. Aleph1 was a third-party provider of extra goodies. The PC card project started off as being just an Aleph1 thing, but later on when we did a big ASIC, that was a collaboration with Acorn because ASICs need serious money, and so they partly paid for that.
So since then, basically, your work is in the whole world, like, is dominating everything.
Yeah, so I used to live in this really obscure corner of computing where nobody knew anything about it, and it's become a big deal in the last few years. So suddenly we get all sorts of people turning up, going, "Oh wow, yes, what's this ARM Linux thing?" So it's been interesting to watch it become popular.
Does that mean your code is in everything?
No, not really. I did write some little bits in the ARM kernel many years back. Mostly I wrote a book because there was no documentation on how to do ARM porting back in 2001 or 2 or something. So I kind of got, how do I write a driver for ARM Linux? What do you do for a new board? So I wrote a couple of articles and expanded that into a small book about ARM Linux, which for years was the standard reference. It was embarrassing that 6 years later that was still something you'd find if you looked for how do I port stuff to a new board. But no, hardly any of my code is as important or in anything.
So Debian and ARM.
So I became a Debian developer because at the time they were one of the few distros that supported ARM. So the very early work was done with Red Hat, but then after that, and BSD actually had much better ARM support back in 2000 than Linux did. But yes, Debian became, because there's always a port that supported a lot of architectures, it was a good place to do that work. And we've always treated them all equally. There wasn't anything special about x86. It may have been a lot more popular, but we always supported Alpha and MIPS and ARM and IA64 and all those things, Power, S390. So there's still, I think there's 13 architectures supported. Obviously, increasingly, the only two that anybody cares about are x86 and ARM and all its various flavors.
But how many actually devices run Debian ARM on the market? It's
very hard to say, of course, because of the way Debian works. It's not a commercial distro, nobody counts. A lot of people use it as a base. Increasingly, a lot of people use Ubuntu as a base, which is sort of Debian. The core stuff is the same. But it's very hard to know exactly how many people actually use Debian directly. I mean, so a company I worked for between Aleph1 and Linaro was Toby Churchill Limited, and they make machines for people who can't speak. So it's got speech synthesis in it and little boards in there, and that used embedded Debian. So that's the project I've been doing since 2004, which is basically shrinking Debian enough to put on embedded systems. So it's always had the advantage that it was easy to get started, but it's not really designed as an embedded operating system, because it's all pre-built binaries, relatively fatly configured with all sorts of stuff you probably didn't actually need. So embedded Debian just shrank the images a bit, but was still fundamentally the same thing.
So Debian is a desktop OS? Desktop, laptop device?
Server, desktop, laptop, exactly, has always been the focus. But actually, people use it quite a lot for doing embedded development because it's easy to get started, supports lots of architectures. You can demo something up, and there's an enormous part of software included. So you almost always got what you need to knock something up, and you can decide afterwards which architecture you're actually going to slim it down to. So some companies work that way.
And now that there's a Cortex A15 Chromebook, is awesome.
Mm-hmm.
You can run Debian, I guess.
Yeah,
very nicely.
That works. Yeah, that's easy.
And the 64-bit is just going to make it for sure. Like, do you expect that by next year's Linaro Connect, everybody's going to use ARM-powered laptops and run Debian and other?
Not quite sure about
OS?
by next year, but yeah, increasingly there's a lot of people here that are already using ARM-powered laptops, mostly Chromebooks, because they're actually reasonably quick and not hopelessly expensive. So yeah, that will become more popular. I mean, ARM-powered netbooks have been around for a little while. There was the Psion let's say they were way ahead of the game. That was 2004. You got a netbook and it ran ARM Linux, but it wasn't really that popular. And then kind of again it started 2010. We had the Toshiba AC100 and the Pegatron machines, which were actually released by Genesee. So some people use those. Quite a nice little bit of hardware. It really does actually last 7 or 8 hours without being fat and heavy. And yeah, now we have Chromebooks, and I imagine there'll be a whole load more hardware like this coming out over the next couple of years.
This year and next year.
Yeah, exactly. So yeah, I think that transition to ARM being a completely standard piece of computing tech for real nerds, it's powerful enough for real nerds rather than just tablets and phones, is underway. And yeah, so we'll have ARM64 hardware this year. I don't suppose it will be in netbooks and laptops for a while, because everyone's concentrating on servers to start with. That's no doubt where the big money is. But yeah, I expect that will happen soon enough.
You never know, no? Maybe somebody releases something.
It's quite possible. So that's always the interesting thing about the ARM, what do they call it, ecosystem of all these different manufacturers making different stuff. You're never quite sure what's going to appear next, which keeps things interesting.
So I think the Chromebook is fast enough for me, but do you think the 64-bit Debian laptops are going to be like an Intel Core i5 or i3 or i7 or something? People just say this is performance is plenty enough.
Yeah, I think it'll be. I guess it won't be as fast as the fastest possible laptops you can buy for a while, but yeah, it'll be enough performance for most people's purposes. As you say, a Chromebook's pretty good actually. It's better than a Core 2 Duo, I'm told, from someone who compared. So your laptop doesn't have to be very old for a Chromebook to be just as good, if not better. And yeah, once we get 64-bit chips, that gives even more performance. There's always a trade-off between power and performance, but ARM chips are working their way up the scale, so for most people's laptop purposes, that's just fine, unless you do an awful lot of software building. And it's easier to do that on a server back home over the net these days anyway. That's how I do all my building. I don't do very much on my laptop anymore.
So how many challenges do you have to make it work?
Basically it works already. We've got a lot of software
huge
still.
Mountains to climb, or
we've got a lot of software still to build. We've built 200 odd packages, 250 packages out of the 18,000 source packages in Debian so far. So we've got quite a lot still to build. That our ARMv8 porting, all the languages haven't been done beyond the basic stuff. C and Fortran and Java work's ongoing at the moment, but we've still got to make Haskell work and OCaml work and Mono work and all these things, which all support an ecosystem of a load more stuff. A surprising amount of things depend on Haskell these days. So we'll be working our way through that pile of software over the next year or so. The thing that Debian we have experts in all those spheres dotted about. So basically, as soon as there's hardware available for them to work on, then they'll port stuff to each new architecture as it goes along. But it's very difficult for anybody else out there who isn't really involved here within Linaro to do much useful work until some hardware turns up. You can run stuff on the model, but it's very slow, so it's not particularly satisfying. And we can cross-build things, but most people will kind of wait until they've got some hardware to use. And one of the things Debian does is makes porting machines available. So there's machines of every architecture available to developers, so that they can run their stuff on it. And if so if anything breaks on a particular architecture, you fix it there.
So people watching this video can join and help?
Yes, we'd love everybody who wants their software to work to try it on a ARM64 machine and fix their stuff.
Where do they click?
At the moment there isn't anywhere to just click. Like I say, there is no hardware. Nobody has hardware, not even us. I'm told that some might start arriving sometime around the middle of the year, later this year. So as soon as some hardware turns up, Debian will set it up and we'll make a porter machine available. I think Red Hat are planning to make a porter machine available soon, probably sooner. But you can already check if your stuff builds or cross builds using the existing stuff. So if you check out the ARM64 port wiki, the Debian wiki, that tells you how to set up a cross-build image, and you can see whether your stuff builds. But obviously, if it depends on a lot of other software, it won't work yet. So